Welcome to our deep dive into advanced cybersecurity techniques. Today, we're uncovering what happened after a device has been compromised, a critical phase known as post-exploitation. In this tutorial, we'll focus on setting up a sophisticated DNS proxy for command and control server communication, a method designed to camouflage malicious network traffic. Let's get started. When a device has been hacked, the subsequent stage is known as post-exploitation. During this phase, a vital tool is the Command and Control Server or C2 server.
A C2 server allows for the centralization of control over infected devices, often referred to as target computers. Through these servers, attackers can issue tasks such as system commands for execution on the target. This enables actions like exfiltrating information or downloading new malware payloads.
C2 servers utilize different communication methods to camouflage their network traffic, make it appear like normal requests to common web pages, while HTTP or HTTPS is frequently used. Other network protocols can also facilitate communication with the server. Here, we'll demonstrate how to set up a DNS proxy for C2 communication. To understand this, let's first explore how the domain name system works.
DNS acts as a translator, helping computers find IP addresses for human-readable URLs like google.com because IP addresses are difficult for humans to remember.
This system extends to subdomains, which are the key element we'll exploit for C2 communication. A standard subdomain request looks like this one. We can send more complex subdomains like this example. If we operate a DNS server, it can resolve this request. A C2 server can host a DNS server to resolve these petitions, crucially sending data that acts as a message between the target and the server within this DNS request. This tutorial focuses on a real environment, not a local lab, typically requiring two virtual private servers. To enable these communication methods, you will need to acquire a domain from a provider. Once you have a purchased domain, you must create a specific DNS records. See this example. An A record maps to ns1.mydomain.com to your proxy server IP, and a name server or NS record delegates cdn.mydomain.com to be managed by ns1mydomain.com. The first server, serving as your DNS proxy and the target of the A record, requires two primary configurations. First, enable IP forwarding. Edit the file and add the next line. Apply the change with this command. 2. Create IP table rules. These rules enable rerouting and change the IP address from the proxy to the C2 server to prevent bad DNS response. For set the pre-routing rule, run this command. Replace C2_IP with your C2 server's IP address, and the $.53 specifies the DNS UTP port. And now, to set the post-routing rule, run this command. On the C2 server, you need to enable input and output DNS traffic. While these rules can be set for all origins and destinations, for enhanced security, it is recommended to enable them specifically for your proxy server IP address. Run the following two commands to enable the input and output traffic. Replace proxy_IP with the IP address of your proxy server, which is the same address pointed to by your A record. After completing the basic DNS proxy setup, you can test it. On the C2 server, run the following command to monitor forwarded DNS traffic. And on another computer, generate test traffic using the following command. Use IP_proxy as a resolver and replace cdn.mydomain.com with your name server record, ensuring to add a trailing dot at the end. If the configuration is correct, you should see the traffic in TCP dump. However, the dig command will likely receive a timeout response because there isn't a DNS server actively listening to provide a full resolution. Seeing the traffic in TCP dump confirms the proxy configuration is functioning for the C2 servers that support DNS communications.
Quick reminder, all the configurations shown in this video are available in a detailed Medium article. You'll find the link right in the description.
To demonstrate with a live C2 server, we will use Mythic. First, you need to install a specific agent and a DNS profile. To install the Poseidon agent, use this command, and then install a DNS profile with this command. It's important to note that the DNS profile in Mythic is in beta version, and currently only works for the Poseidon agent, specifically target Linux and Mac OS systems. After successful installation, Mythic should display the installed profile and agent in the Payload C2 service section. Follow the next steps to compile the payload for your configured infrastructure. In the Payload section, select Linux as the target operating system because the Poseidon agent is used. For the payload type, select the installed Poseidon agent and add DNS to egress C2 profiles. In command parts, proceed by clicking Next, because Poseidon includes a default set of commands and do not allow dynamic loading. In the profile configuration, choose DNS, set a callback interval, in my case of 5 seconds, and a jitter with a value of 2. This setting reduces the time between requests, which is beneficial for testing. For IP port, add your proxy server IP address followed by the port 53 like this example. In the series of domain to use, add your name server record. You have the option to include more domains. Finally, set a name for the payload and build it. Once the payload is compiled as a Linux binary, transfer it to the target device. For example, I use a Kali Linux virtual machine with a bridge adapter network configuration. To execute the binary, use this command. First, rename the binary, make binary executable, and then execute the binary. You can run Wireshark on the target to observe the DNS traffic from the target to the C2 server. Use the filter to exclude extraneous traffic. The target will send requests to the C2 based on the configuration, callback interval, and jitter variation. If all is set up correctly, Mythic will receive the callback connection and Wireshark will display the expected traffic. With the callback active, you can create tasks for the target. When the target sends a DNS request, it receives the task from the C2 server, executes it, and then returns the result back to the command and control server through the subsequent DNS communication. And there you have it, a compressed guide to setting up a DNS proxy for C2 server communication. This technique highlights how attackers can leverage common protocols like DNS to maintain stealthy control over compromised systems. Understanding these methods is crucial for both offensive and defensive cybersecurity strategies. Thanks for watching, I'm Osai, and if you found this tutorial helpful, drop a like and subscribe for more cybersecurity content. Also, feel free to follow me on socials, they're up on the screen. See you the next time. Note the threat and stay safe.
If you're passionate about malware and cybersecurity, I've got something awesome for you. Check out our academy focused on ethical malware projects. We offer a range of courses to boost your skills. First up, there's Introduction to Windows Malware Development for those getting started. Next, dive deep with Building a Custom RAT to create your own remote access tools. And for those wanting to analyze and understand malware, there's Introduction to Malware Analysis. But that's not all. We also have our Malware Development modules, mini courses that cover specific topics like evasion techniques. Join us and level up your skills.